It's now well established that the synaptic transmission of information between two neurons can be made more or less efficient by a third party through a process called neuromodulation. This process, as you'll see shortly, is in some aspects very similar but also very distinct from the synaptic transmission mechanisms we've seen previously in the course. Before we dive into the details, let's briefly remind ourselves about the classic view of synaptic transmission, in which information is typically exchanged unidirectionally from one neuron to another. Most often, this occurs through chemical transmission, in which neurotransmitters are released from the synaptic terminal of a presynaptic neuron and diffuse across the synaptic cleft towards the dendrites, soma, or axon of a postsynaptic neuron. There, the neurotransmitter molecules bind, for example, to ligand-gated ion channels, and exert their excitatory or inhibitory potential. During neuromodulation, this classic synaptic transmission still occurs, but that's also where the similarities end. So what's different? In a nutshell, neuromodulation is the process by which the synaptic transmission process between two neurons is either enhanced or decreased through action of a third substance, the neuromodulator. Let's draw the following analogy. Imagine you're out at a nice restaurant, on a date, and deep in conversation with your future love interests, excitedly engaging and exchanging information just between the two of you. Along comes your ex-partner, approaching your table directly, clearly with the intention of interrupting your two-way conversation. Now, this can go two ways, depending on how your prior relationship ended. Either your ex approaches you with a smile, a friendly, "Hello, how are you? So good to see you here." Or he or she makes a jealous scene and embarrasses you in front of your date. Chances are that depending on that interaction, your current date will either see you in a more or less favorable light after this interruption, and your two-way conversation will certainly be changed. Either way, your ex will very likely have had an influence on the interaction and outcome of that particular date. That's exactly what neuromodulators do. So what are these neuromodulators? As we'll see shortly, neuromodulators are often other neurotransmitters, or small molecules, released by a third neuron, making a synapse with either the pre- or postsynaptic neuron of interest. There are many types and definitions of neuromodulation, but the mechanisms through which they act are very similar, both locally, like affecting a few neurons in close proximity, or systemically, affecting large areas of the nervous system at once. Mechanistically, most neuromodulators act through G-protein-coupled receptors, or GPCRs. They can also act through voltage-gated ion channels. And neurotransmitters can regulate the excitability and activity of neurons by affecting the synaptic strength and communication between them. This is a process that can be measured experimentally, and its study has significantly contributed to our understanding of brain function. Let's learn more about how synaptic strength and transmission can be modulated both pre- and postsynaptically, how it can be measured experimentally in many creatures, and broadly, what systems exist that make this physiological process possible.